don't know if I made it in time. I just had a bit of a technical glitch. Apparently YouTube's primary servers are down, so I had to abort and switch to the backup. And it is already tomorrow, so I don't know if that quite made it. I hit the button, and then it started streaming, and then it became 12, and I hadn't gotten the live indicator, but we will see what the timestamp says. We'll see. Okay, today is itertools, which is pretty cool. Itertools is a module that provides tools for iteration. Let's start with some infinite iterators. How about t equals itertools dot count, and let's start from 5 with an optional step of 2, and probably like this. Pretty simple. C equals itertools dot cycle. I really hope it counts as today, yesterday, whatever. Because that I was counting on that server being up when I hit the button. But instead it just kind of sat there for a while and didn't do anything. Anyway, PIS. How about a range of 3? So this cycles through an iterable. It basically loops through an iterable, and then when you get to the end, it starts at the beginning again. C equals itertools ls dot repeat. Element about 5. So we just get 5 forever. It repeats an element. What if we do 3? And stop iteration. This is the only this many times. So it's the equivalent of, if we have 5 and 3, it's the equivalent of 5 times 3, pretty much. Except it's not, it's more like, more like a generator. 5 for I in range 3. It's more like that. Accumulate. To keep adding to a... This is a pattern called map reduce, which you may have heard of. Reduce takes one large iterable and starts with the first element, and then takes the second element and performs some calculation involving the first and second elements to produce a result, and then takes the third element and does that same calculation with the current result, and so on and so forth, with whatever function you want. And accumulate does oh, I can pass a function. I guess the default function is sum. Let's try range 5. So a range object with 5 in there has 0, 1, 2, 3, 4. So we have 0, 1, 2, we have 0, and we start with that, and then we take 1, and 0 plus 1 is 1, and then 1 plus 2 is 3, and then 3 plus 3 is 6, and then 6 plus 4 is 10. And that's all we have in there. It makes perfect sense. And let's try something else. Lambda x and y of x times y. Does that work? Can I do that? Next, C. This probably won't work. It'll just be 0 the whole time. That's right. Let's do something else. Let's start at 1 and go to 6. So we have actually 1 through 5. So we're going to start at 1. And then this time, we have our accumulate function, which takes 2 arguments and multiplies them together and returns that. So we have 1, and 1 times 2 is 2, and 2 times 3 is 6, and 6 times 4 is 24, and 24 times 5 is 120. And then we have a stop iteration. Neat. So this can be any function you want. I used a lambda just so I didn't have to define something specifically. Chain, this is a good one. List itertools dot chain 1, 2, and ABC. List. There we go. Chain takes variadic argument, which means you can pass it as many arguments as you like, and it will go through each one and kind of split it up. You can see what we have. I have a list of 1 and 2, and so it went through this and produced 1, and then produced 2, and then it produced A, and then B, and then C. Chain from iterable. And this chain dot from iterable. I think this will not work. Yeah, takes exactly 1 argument. So I need to say group that, and then we can do it. Or if we did have an iterable and we didn't have chain from iterable available, we could just unpack it and be the same thing. I'm not super clear on the difference between these and why we need them both. Compress. Interesting. Okay. Itertools. Let's just turn this into a list. I sent it to list because itertools is the functions in it are generally lazy, meaning they produce 1 result at a time and only when you ask for them. That's why I had to keep doing next. List itertools dot compress. A, B, C, D, E, F, and this is from the documentation, this example, with 1, 0, 0, 1, 1, 0. Okay. And compress and list. And what this does is you get an iterable, and then whenever you have a you have an iterable and I suppose another one, and whenever it kind of chooses which ones to keep from your first iterable based on whether the corresponding element in the second one is truthy or falsy. So 1 is truthy, means we get A, and then 0 is falsy, means we don't get B, and we don't get C here. And then we get D, and there it is. And E we should also have, and we do, and F is not there. So I'm sure that serves a purpose. Dropwhile. Interesting. I had not heard of dropwhile, but I had heard of takewhile. So let's do that. List itertools dot dropwhile, and it takes a predicate first and then a sequence. Lambda x about x less than 3, 4, whatever, and range of 10. Fix the dropwhile in the list. So what this does is it takes an iterable, like this range object, and for each element it sends it to the function here, and if that function returns a truthy result, that element is dropped. And the while means that it keeps doing this until we find something falsy. So 4 is not less than 4, so we put that in there, and then we continue after that. That's odd. There's a filter false. See what we get out of that. Same thing. So there's a built-in function called filter, which allows you to send in an iterable and a function of some kind, and it sends each element of the iterable to that function, and if the result is truthy, then the element is accepted, basically. Filter returns another iterable. In Python 2, filter returns a list already. In Python 3, it is a filter object, which you have to actually iterate over because it is lazy. So this filter false is the opposite. It only includes elements that do not match. So let's try, instead of this range object, let's try 1, 2, 8, 9, and 1. So that only includes 8 and 9. So instead of only including the things that are less than 4, it's everything else. And let's try that with dropwhile. So we skipped 1 and 2, but then 8 is no longer less than 4, so we get everything else, including the 1 that would be dropped if it were before the 8. But it's as soon as we see something that doesn't satisfy this condition, we take everything else and stop checking. Group by. I've heard a lot about this one, never quite used it. Let's do that. Group by, an iterable with a key function, sub-iterators grouped by value of key function with v. Don't really understand that, but this one is the other way around. We get the iterable first, and then how about let's actually make this different. How about just a range object again, from 2 to 25, and let's say The function is lambda x. Don't really know what's going to happen here, but let's find out. X mod 10. No, let's do integer division by 10. Okay. What does that do? Alright. For item in the thing that was just returned to the interpreter, which is what the underscore does in the Python shell, we're going to print item 0, and we're going to unpack item 1. So we have 0, 1, 2, and 24. That's interesting. 0, and we have this grouper object. So we unpack that, and I guess there was nothing in there. 1, and then 2, and 2 had something, because we have 24. I'm not clear on that one. I will go to the actual documentation. Returns consecutive keys and groups from the iterable. The key is a function computing a key value for each element. If it's not specified or none, it defaults to an identity function and returns the element unchanged. Generally, the iterable needs to already be sorted on the same key function. This works on sorted things generally. I have heard that before. Generates a break or new group every time the value of the key function changes. Okay. For key and value in this, print value. Okay, let's do that again, and remember to unpack it this time. Nothing, and 24. The group itself is an iterator. Oh yeah, it has to be sorted. Shouldn't it be? If we do integer division by 10, we first get 0 a bunch, and then 1, then 2. That should be already sorted by that. Groups.append a list out of them. I don't know why it doesn't particularly show. How about an example? Do we have one of those? We do not. Okay. But we do have 3 groups, and that's things that are divisible, that when you divide by 10, the result is 0, and that's 4 through 9, basically, or 2 through 9, sorry. And then once you get to 10, you divide that by 10 and get 1. So we start with 0, right? And then we have 1, and then 20 to 24 are, when you do integer division by 10, you get 2. So, let me check this thingy. Anything there? No, not yet. Okay. So, what is this doing? I'm unpacking this, but it only has 24 in it. Let's try something closer to the example. Go by A, B, D, O, A. Great. Not very helpful. Maybe it's this list call that's messing things up? Who knows? Ah, there we go. So it didn't like that I was sending it to a list call first, and then everything was exhausted. So there it is. There you have it. We have 2 through 9, and then 10 through 19, and 20 through 24. And this is sorted by the result of whether it's of what we get when we divide by 10. Cool. So that was that problem. That's why that wasn't working. What is this exactly? Start, stop, step. So this looks like a kind of slice clone. I'm not sure. Itertools dot islice. B, C, D, E, F, G. Everyone understands that. And let's say we stop at 4. So we have 0, 1, 2, and 3. And how about starting at 1, going to 4? Should cut out A. Indeed. Let's go every 2, and this should only have B and D. But, of course, we could just do that. So, I suppose it just keeps iterating over the thing and kind of does it manually. Maybe it works on something that doesn't support slice notation. So let's say we have item for item in this, and that's now a generator, and we cannot slice generators. How about this? Item for item in that. How about now? So this works with iterables that do not support slicing and indexing. So that's cool. Star map. What? Takes a function and a sequence. Pow, 2 and 5, 3 to 2, 10 to 3. Oh. I see. Okay. For actually, let's just do this again. Itertools dot star map. Okay, here's the star map. Here's the list. All right, let's write some more stuff. Star map takes a function and a sequence, and it sends everything in that sequence to each function, to that function, I mean. So let's have print, for example. And then let's have an iterable of, a sequence, I mean. How about one more? let's say ABC 1 and A and 3 and 4. Didn't like that. It needs iterables. So what I thought this would do is, oh, an iterable it needs to be. Okay. Now it doesn't complain. So what this does is it takes this function, and we have this iterable, and it goes through each item in the iterable, and that item is this ABC, which I didn't really need to put in parentheses, it doesn't matter, and this tuple of 1 and 2, and this tuple of A, 3, and 4, and it will repeatedly do, basically does, for item in sequence, function star item. That's pretty much it. So it worked fine on ABC, and when you unpack an iterable and send each element individually to print, the default separator is a space, so that's why we get A and then space, B, space, C. This failed because we can't unpack a single item. And then I put, you know, another item in there. And you can unpack a tuple, you can't unpack an integer, which is all that is. So then it was happy, and it printed all those things. And then, since I had sent this to list, it just evaluated this whole thing, and the return value from each of these print operations is none, because print returns none, and then we got none and none. So that's a side effect sort of deal. Let's do something else. Set. How about? Oh. No, it has to be something that accepts multiple arguments. Let's do the following. I'm turning these all into singleton iterables. So each one of these is a tuple with one item in it that contains something else, and then we'll unpack this tuple and get whatever's in it. And then we get a set of this, and we get a set of 1 and 2, and we get a set of 3, 4, and A. Notice how the order changes. That's because the order of a set is arbitrary. It's just a hash table. Take while. Predicate first, lambda x less than 4, let's say, and range 10, then take while on the list, and we sent 0 to this function, and 0 less than 4, that's true, so we included 1 less than 4, that's true, and true, and true. 4 isn't less than 4, it's exactly equal to 4. And then we said only keep taking elements while this is true, and it stopped being true, so it finished. Note that if you have an iterator that you made with like the iter function sort of thing, and you save that, then let's do the following. what do you think I will get when I say next I, the next thing in the iterator? Any guesses? Anyone? Where did 4 go? It took 4 from the iterator and then said it does not meet this condition and stopped iterating, but it did take the 4. So that's gone. I suppose you could do a group by. And then for kv in group by, and we need this first. It's backwards for some reason. Sometimes they like to change the order of things. Print star v. So what did we get now? X is less than 4. That was true for 0, and true for 1, and true for 2, and true for 3. And then we checked 4, and it was false. So that changed from true to false, so it made a new group and started 4. Now we have all of the values that were in our iterator. Fantastic. T splits one iterator into n. Let's do this. For x in itertools.t, I n2, I don't know, print x. What do we get? Great, thanks. Let's unpack it, shall we? So we get more iterators. So it copies them, basically, but a deep copy, I suppose. It splits one iterator into n iterators. So we had 2 over here, so it gave us 2 iterators of this range object. 2 iterators of the iterator of the range object. Ziplongest. I'm sure you've all seen list zip abc def, that we get A and D, and then B and E, and then C and F. What if we have this? That G was thrown away because it only goes through the iterable with the shortest length. So what we do to fix that, if we want G, is we say itertools dot ziplongest. Python 2 has a similar method called iziplongest for an iterator out of ziplongest, and the ziplongest function in the itertools.ziplongest function in Python 2 returns a list, kind of like zip in Python 2. And now we got none, because we went all the way through ABC and there was nothing left. And there's G. What we can do if we want is do I think it's fill value equals I don't know, 4. And now we get 4 for everything that's left. Let's say H. And we have 4 here and 4 there, so that's fine. Great. Half an hour. I think we've gone through infinite iterators and iterators terminating on the shortest input sequence. Next is combinatoric generators. That's very popular for statistics and stuff. The Cartesian product, permutations, combinations, combination with replacement. Itertool functions. Is that it? Really? Accumulate. And now it's just the listing. Maybe we'll just go through them. Recipes, I don't need that. Okay. Let's just do that. Product. The itertools dot product is the Cartesian product, which is equivalent to a nested for loop. Let's do ABC and DEF. Lots of stuff. We have A and then D, and then we stick with A, we go D, E, F, and then we go to B. We go D, E, F, and it continues with C and then D, E, F, which is equivalent to list A, B for let's see now. A in ABC for B in DEF. Same thing. See? But what if you don't know how many of these things you'll have? Maybe you have ABC and DEF and then 9, 26, 15. Then you'd need another level of this for loop for A and ABC, for B and DEF, for C and 9, 26, 15. And it would just go on and on and on, the more things you had to go through. But this lets you just list all the things without making more loops for all of them. And if these are in a if they're in an iterable, like they should be, you can just use the star operator to unpack it. Like if you have x equals ABC DEF, and then we send star x. Perfect. Because this takes the x over here and unpacks it, sending basically ABC and DEF kind of separately. Same thing like we do here. But x could be anything, any size of stuff for as many iterables as we want, and it would just be this. The same thing. Wouldn't have to change it. That's good stuff. How about permutations? Expected int as our. Oh, that's my bad. Doesn't work the same way. List itertools dot permutations, and then ABC, and let's say 2. AB, AC, BA. Notice how this contains the same elements as this one. They are not unique. Permutations, it doesn't just look at unique elements. The order matters. So AB is distinct from BA. And we have BC, CA that we also had here, and CB that is almost out of the frame. We could do 3, and we would have 3 elements here, 3, 3, 3, etc. What happens if I do 4? I don't know. Nothing, because it isn't able to get 4 things from there, so that's great. How about combinations? AB, AC, and BC. The rest were the same, except with different order. So with combinations, the order of each element, of each item over here, doesn't matter. AC is the same as CA, so it only gives you one of them. product, permutations, combinations, combinations with replacement. Let's try that. With replacement. Are length tuples in sorted order with repeated elements. Aha. So now we have more saying that we can replace. So the with replacement means we take an A and then we put it back in. And we get the same A when we take something out. A, B, A, C, and then we take out B and put it back in. And then we can take B again. So that's what with replacement does. That's cool stuff. Very handy. And the rest, I basically just went through a very short version of the documentation that's at the beginning of this page. Just saying, for example, it's just charts, tables with iterator, arguments, results, example. Iterator, accumulate, arguments p and an optional function. Results, p0, p0 plus p1, p0 plus p1 plus p2, and then example, accumulate with, a list of 1, 2, 3, 4, 5, and then resulting in 1, 3, 6, 10, 15. So, and then the rest of this page is large paragraphs of explanation and examples, except for group by that didn't have an example when I was looking for it. And yeah, islice, permutations. So yeah, this is all of that's itertools. It's very handy. Let's see which ones are my personal favorites. Count, cycle, and repeat, not really. Chain is pretty good. Prevents you from having to make a bunch of loops. Compressed I've never used. Dropwhile never used. Group by I've seen sometimes. Maybe you want that. Islice and star map. Take while I've used. Ziplongest I think I've used. And I'm pretty sure product and either permutations or combinations. One of those. Those last ones are also very popular for people doing statistics or discrete math or something, because you want to find out how many ways can you put the elements in this thing together. Which of course relies on knowing that what you're doing is the Cartesian product that has a name, and then you can Google Python Cartesian product and get great solutions like this one. There's already a function. Some people don't know what it's called, and they just know what it looks like and what they'd like to do. But yeah, so they end up making something messy with a whole bunch of for loops, and then they say, what is this? How do I do this? And then it's like a Cartesian product and itertools.product. So that is the stream. Tomorrow there will be a game on stream, hopefully a little earlier. Kind of annoying that the main server was down today. So yeah, I hope you liked learning about itertools. It's just a whole bunch of clear and generally useful functions. Not really super specialist, like a lot of the stuff in statistics is if you're doing statistical calculation on stuff, but this is might be kind of generic for various programming tasks. So yeah, cool stuff. Thanks again. Join me tomorrow for a game. I don't know, most likely LOL, but we'll see. And I will see you next time. Have a good one.